Welcome everybody to our podcast. It's Melissa.
And Nadine.
And this is our show, The Tapestry of Your Life. And today, I'm going to talk about space.
This is awesome.
I am very excited. So on Sundays, I normally share facts with the congregation when I do announcements. And so this is one of them that I got to share. Okay. And first, I got this book called How Space Works. It's got hundreds of pages. I got it at the Barnes & Noble bookstore, which was, my friend took me there for my birthday, and I had so much fun finding these books. Thank you. It was so cool to find these books all over the place. It was like my own treasure hunt.
Yes, because they didn't group them together. They grouped them by subject matter.
Yeah, so I have one on how space works, another one how the brain works, and another one on how the body works. So now I have 4. I need to find out what other categories, other subjects they have. Okay, so about space. In my book that I have, it talks about the center of the Milky Way. So have you ever thought about what's at the center of our solar system or our galaxies before?
No. And I was sitting beside Melissa's sister this morning when Melissa says, I woke up real early this morning and I was thinking about the center of the Milky Way. And Emily and I look at each other. I said, I know. You're thinking about the candy bar, the Milky Way. That's the only center you've thought about.
Yeah. It didn't even cross my mind that the Milky Way was also a candy bar. Because I just love stars and space. So, when someone says Milky Way, that's my first thought, is the stars in space.
Yes, so you can let us know what you think of when you hear Milky Way. Is it a candy bar or is it outer space?
Yeah. So, at the center of the Milky Way is basically a giant black hole. Which they have said that a black hole is basically like an exploded star that folded in on itself. Okay? So, with what's in a star. What are you doing?
The wall beside you has stars and the moon on it.
Okay.
And I'm like, wow, she's talking about the stars.
The moon and the stars and everything.
And it's right there beside you, but you can't see it because you're looking this way. But I see it. It's in front of me.
Okay. All of a sudden, you just started holding your phone up. I was like, what am I doing now?
I'm taking a picture.
Okay. So, at the center of the Milky Way is a black hole, which is basically an exploded star that folded in on itself. So, they say that nothing can escape, including light.
What? You said the Milky Way was a star that folded in on itself?
No, at the center of the Milky Way is a black hole. And a black hole is a star that has exploded and, caved in on itself.
Wow.
You're doing the slow blink that my sister Emily does when I'm talking.
I thought when a star exploded, it disintegrated. I never thought of it folding in on itself.
Yeah. Well, there's different ways that it happens.
That's a big star. Because how big is the black hole?
It's enormous.
So that was an enormous star.
Yes.
That exploded.
Mm-hmm.
Okay, we won't get off track. Talk to us about the Milky Way.
Okay, so in this exploded star, right, in this black hole, in its center is a mass, right? And it's a mass of what we would call radioactive material. So iron, metal, uranium, all of those kinds of things that are very, very heavy elements. That's what's at the center of them, okay? So what's being produced at the center of this massive black hole is radio waves and gamma rays, okay?
Radio and gamma.
Yeah.
Got it.
So, I look at my chart again. But on the spectrum of light, okay, the electromagnetic spectrum, we can see visible light. It's just a short, little sliver on this whole spectrum. So, there's low frequency and then there's high frequency. So, low frequency electromagnetic stuff is microwaves, infrared, right? When you use those heat cameras and things like that.
Yes.
That's all infrared, right? Power lines, TVs, remotes, even your cell phone, all of that is low frequency stuff. Okay. So, and sound waves are part of that, okay? Now, on the higher side of things is ultraviolet radiation, which we use for germs, seeing germs and things. X-rays, and then you have gamma rays, which is the radioactive. So that's the highest they can possibly be, okay?
Okay.
So, with these different waves, there's sound waves and the gamma rays. gamma rays are the most powerful. They are essentially like pure light, is what they are.
Wow.
I know. And even though they come from such a heavy mass because it's radioactive material, it shoots off particles that are essentially weightless. That's what gamma rays are. So it's traveling like so fast, like at the speed of light, because it is light and energy in of itself, that there's like no mass to it, and it just fires off. And there's like, it takes like, I think they said like 3 to like 6 feet of lead to like stop these particles, because they just like go so fast.
Wow. And where are these gammas?
So gamma rays, they are in outer space mostly, with radioactive, like the stars and the gases and different things. So at the center of the Milky Way, in that black hole, there's a lot of radioactive material because of like the metal and the particles and that kind of thing. So the gamma rays is what's like shooting off as a reaction of these things bursting and colliding and that kind of thing.
So is there gold in this space? Since you said there's metal in space, is there gold and diamonds?
There actually are diamonds on Saturn. Because of the pressure of the atmosphere, it rains diamonds.
I do remember that.
Yeah, I'm pretty sure it's Saturn.
Yeah, I remember that.
So there is different things like that in space. I don't know if there's gold, because gold is, as we know it, at least here, is like a soft metal. And all of these other ones are like very, very hard and hot. But
well, there's gold in heaven, so it's got to be out there somewhere.
Yeah. I'm sure it is. I just don't know how.
While you were talking, I just realized I never thought of precious metals and things like metals, precious gems, jewels, all that stuff. You always think of people mining for it, so you always think of the ground.
Yeah.
Below you. But I never thought of the air above me.
Yeah.
So this is good.
You could literally just pick them up like in space.
Yeah.
Yeah.
Okay.
Like it's such an abundance, right?
Yes.
Like the resources really are unlimited. Like a lot of people I think like the earth is going to run out of supplies and materials, which one, it won't, because there's such an abundance. But two, even if it did, like we could literally go to space and get some of these things. Like,
yeah. Let's go to space, like go to the grocery store.
Yeah.
Nice. I like it.
Yeah. So there's sound waves and there's light inside of the Milky Way. And I just think it's amazing that something weightless comes off of something that has such like mass to it, right?
Right.
And it reminds me of like the glory of God, right? Like, so the glory and the presence of God is typically something very heavy, but the light that emanates from all of that and that emanates from God is not heavy at all. Like, it's pure, it's fast, it's weightless. There's no, like, it's not burdensome at all.
That's why Jesus said in Matthew 11, take my yoke upon you and learn from me. My yoke is easy and it is light.
Yeah.
Wow. That paints another picture of what he means by light and easy.
Yeah. And so on this spectrum of light, right, with all of these radio waves and different things, so the radio waves and microwaves, those are all considered like non-ionizing, while gamma rays, X-rays, those are all considered ionizing. So the difference between the two is just basically the strength. Non-ionizing are the waves and particles that will just cause them to like vibrate. Okay? So like when you have like speakers and different things, you know how you can feel it in your chest sometimes,
right?
Because it's the air that's vibrating from like the waves that are coming out.
Okay?
So those are a lot of things that we're used to. The X-rays and the gamma rays and ultraviolet, those are the ones that are way more intense. And the reason for that is because since they're such high frequency, they actually have the power inside of them to knock the particle in a different direction instead of just causing it to vibrate.
Okay, so it reroutes it.
Yeah. It can move it. It can actually knock it apart and different things. So like the atoms have, like different parts to them.
So is this how the stars explode? A gamma ray exploded it?
That's one way, yeah.
Oh.
So with that, like X-rays, so like gamma rays can completely knock particles all the time. And X-rays only do it some of the times. And that's because with X-rays, they have the reaction taking place on like the outside,
Okay.
while the gamma rays have the reaction taking place on like the very inside, like at its very core. And so all that power comes out and will dislodge other particles that are around it and completely like shift them, blow them apart, anything along those lines. X-rays will do that, but not to that extent. And it's because it just doesn't have as much power because the reaction's only taking place on like the surrounding part of it.
Wow. I'm thinking of how God came to live inside us with Holy Spirit. So
Yeah.
the gamma rays are working on the inside, just like the power of Holy Spirit on the inside. How much more effective that is than just vibrating on the outside before Holy Spirit was sent to live inside of people. Like in the Old Testament, he just came upon priests, kings, and prophets. So that's like he was vibrating. He was on the
shaking
outside.
them up, yeah.
Yeah, so the effect of Holy Spirit was a lesser degree. And look what happened.
Yeah.
And now, today, we have, as believers in Jesus, we become a new creation. Now we can receive Holy Spirit on the inside of us. So we're like gamma rays.
Yeah. Well, and that's what I was thinking of when I was reading this. I was like, wow, at the core of our galaxy, the Milky Way, right? There's sound waves and there's light, and light that's exploding like everywhere. And I was like, I know I have heard before that like our cells, right? There's at the very core of our cells, there's a sound wave as well. So then I was like, well, I wonder if there's also light at the center of our cells as well. And there is. Like, so I just think it's amazing that like the God of our universe, right? The master of the universe who created everything with his words, it's the same substance in the stars and in the heavens and at the center of our galaxies that everything rotates around. Like, it works that same way in our bodies too. So I looked up light in our cells, and all of your cells have light in them. Like, that's how they communicate between one another. It's like firing electrical light signals at one another.
So like dolphins like have those clicks and chirps and sounds that they send. Our cells are a similar thing with light.
Yeah, and it holds light as well. So I saw this guy, this Russian scientist person. His name is Peter Garyev. I have no idea how you say his last name. But he put DNA inside like of a quartz container and then zapped it with a laser. And so the DNA is like glowing and absorbed all of the light that was put into it by this laser. And then he took away the DNA out of the container, and it was a perfect light imprint of the DNA that was left like shining right in its place where the DNA was, but the DNA wasn't there anymore.
Wow.
And so he was saying that there's something holds the light in place, right? And he said, you gotta find how he said it correctly.
Something holds the light in place.
Yeah.
To hold the imprint.
Yeah.
Okay.
I forget exactly how he said it. So, but basically that there is a blueprint of our entire body in a field of light is what he said. That like our DNA, like there's an imprint of us, like a blueprint of us in a field of light that our bodies are basically like mirroring. And so this is the whole idea of like quantum physics and different things, how particles on opposite sides of the planet and the world and everything can communicate like at exactly the same time. Like there's no delay between them, even though they're thousands of miles apart.
Right.
And so the other thing they were saying is that looking at also the cells, it says they think that the cells send and receive messages like at the speed of light or even faster, because it seems like they used to think it was a very linear thing. Like, oh, this cell reacts with this cell and then it relays down and it communicates that way. But they said it looks like there's like almost like a conductor, because the cells are communicating and acting like separate from each other, but as if they know what the other ones already need. So like, you know how a conductor of an orchestra is like coordinating this one and this one all at the same time, so it all works together like seamlessly.
Right.
That's what they were saying, how like cells work, that it seems like it's like a symphony where like they're just all acting together without communicating because they're communicating so fast. Like, it's almost like preempting it.
Right. That's awesome.
Yeah. So I was so excited this morning when I was awake and reading all of this stuff about the Milky Way and like going down all of these like rabbit trails, because I was like, well, gravity and space and time. I was like, I don't understand how this works, which there's so much more to this with like mathematics too and like dimensions. So fascinating. But I was just very excited that like to find out, one, how everything is orchestrated together, and two, that you can't destroy the light. Like, when you absorb the light into you, you take it with you, but you can also leave it the places where you've been. I know here at church we've learned before, like, you can take atmospheres with you, right? We can take the atmosphere of church wherever we go. And we can also leave that atmosphere in that place as well. So that way we leave it better than the way we found it.
Yes. Wow.
So yeah, that's what I have to share on space.
That's awesome.
Yeah.
I've learned a lot.
Yes. I did too. It was fun researching all of this.
Thank you.
Yep. Thank you, everybody, for joining.